Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the quantum numbers. Based on this topic, students, quantum numbers, I'm going to solving the previous year's questions, students. This is the topic from structure of atom. This is the NEET preparation series day 1. Okay, now next continuation, next bits day 2. In day 2 series, I will discuss, students. This is the NEET preparation series day 1. Okay, so previous year's questions I'm going to solving. First question, how many electrons can fit in the orbital of which n equal to, for which n equal to 3 and l equal to 1. See here, students, how many electrons can fit in the orbital of which n equal to 3 and l equal to 1. N equal to 3 is nothing but what, students? Third shell. N is equal to what? Principal quantum number. L is equal to azimuthal quantum number given. So n is equal to 3 is nothing but third shell, students. Are you clear? Third shell. L equal to 1. So L equal to 1, first of all, you see, students, what are the shells, Nana? Shells 1 2 3 4. Here you are taking the number of shells 1 2 3 4 we can take. Okay, and next L is equal to 1. Values, L values, what, students? What I told you, L values in the previous video, quantum numbers. L values for S sub shell 0, P sub shell 1, D sub shell 2, F sub shell 3. You have to remember this one. And next, coming to the M values, students. M values, this is which one? Magnetic quantum number. This is principal quantum number. N values, this is L values, this is M values. For S subshell, students, for S subshell M value, how much? S subshell M value 0. For P subshell M values what, students? P subshell 0. For P subshell kadama, so minus 1, 0, plus 1. So this is for Px, this is for Pz, this is for Py. Okay, and next D subshell. I am taking D subshell. What are the M values? In D subshell, total 5 orbitals will be there. So that's the values minus 2, minus 1, 0, plus 1, plus 2. Okay, now so plus 1, plus 2. These are the values. So minus 2 is nothing but this is dxy, this is dyz, this is dz square, this is dxz, this is dx square minus y square, dx square minus y square, students. Okay, Namma? So this is about the m values. And coming to the s values, students, what are the s values? For s is equal to plus half. That means if electron is like this, there means plus half. If electron is anti-clockwise direction, there means you have to take minus half. Are you clear? Okay, Namma. So for example, in S subshell, electrons we are representing like this. This is plus half, this is minus half. This is clockwise, this is anti-clockwise direction. Okay, now see, students, this bit what I asked, how many electrons can fit in the orbitals for which n equal to 3 and l equal to 1. N equal to 3 is nothing but which shell, students? Third shell. L equal to 1. L equal to 1 means azimuthal quantum number value 1, means which subshell, that is P. Are you clear? 3p. So it is 3p, students. Here question is how many electrons can fit in the orbitals are asking. So in 3p, how many electrons can fit? And before that, I am going to discuss you in S subshell, students, how many electrons will be there? 2 electrons. In P subshell, how many electrons will be? In P subshell, how many orbitals? 3 orbitals. Okay, now how many electrons? Total 6 electrons, students. Now coming to d orbitals, how many electrons? 1 2 3 4 5. 1 2 3 4 5 6 7 8 9 10. 10 electrons will be there. 2 electrons, 10 electrons. This is 6 electrons here, and this one is 10 electrons. In F subshell, total 7 orbitals kada. So total 7 orbitals, 1 2 3 4 5 6 7. Okay, total 7 orbitals. How many? 14 electrons will be there. Now see, students, here 3p. In 3p, how many electrons are there is asking question. In 3p, third shell, p orbital. In p subshell, how many electrons are there, Nana? 1 2 3 4 5 6. Okay, na? So in total, how many electrons are there in the third shell? So just directly also you can write it, students, because we know the formula. The number of electrons in shell, formula what? 2n square. Are you clear? 2n square formula we can use. Understanding, students? In the third shell, how many electrons? 2n square. Okay, 2n square formula, this formula also remember students, but here asking only particularly 3p. 3p is nothing but this is third shell, this is 3p. How many electrons students in p subshell? How many electrons can accommodate? Only 6 electrons can accommodate. So answer is how much? 1 2 3 4 5 6. Understanding how many electrons can fit in the orbital in 3p. Understanding students, n equal to third shell, L equal to 1 is nothing but L1 value means P subshell 3p. So 3p in P subshell how many orbitals? So total 3 orbitals. So 3 orbitals how many electrons? So 6 electrons. So that's why answer is 6 electrons. Option B is the correct answer students. Are you clear this one? And here one more formula, the number of electrons in subshells. Okay, now in the given subshell is equal to 2 into 2l plus 1. So these formulas you remember students. And next thing is number of orbitals present in the shell. Number of orbitals present in the shell is equal to formula n square amma. So these formulas you just remember students. Formulas are important. Here what I discussed, L values, M values, this all remember students. Then you can do any type of bit, you can easily answer this. Understanding? So now coming to the second question, see students. See Nana, which of the following pairs of d orbitals will have electron density along the axis? Along the axis asking. So d orbitals shapes. So in the last previous video students, I discussed shapes of orbitals. D orbitals total how many d orbitals students? Total 5 d orbitals. 1 2 3 4 5 dxy, dyz, dzx, dx square minus y square, dz square kada. So here dxy shape, what I told you, dxy, this is x-axis, this is y-axis, here this is the dxy, correct, and this is dyz. Okay, now dyz, and this is dzx. Just you can take any type of axis students, zx. Okay, so this is the dzx. Coming to dx square minus y square, what is the shape? This is x, this is y. You take dx square minus y square is nothing but along x-axis, along y-axis, double dumbbell shape. And another one is dz square, that is along the z-axis, like this you have to take, and here one sphere will be there. This is dz square. Are you clear? This is dx square minus y square, this is dxy, this is dyz, this is dzx, correct? So before last class I discussed you this one, shapes of orbitals. Now see students, here in 3 orbitals, so no, in 3 orbitals dxy, dyz, dzx, so what happens students? Here these are lobes kada, pairs of d orbitals will have the electron density. That means electron density is present in between the Cartesian axis here. Yes or not? These lobes are present in between the Cartesian axis here also, but these lobes are present along the Cartesian axis. That means that is electron density is present along the Cartesian axis. Here also electron density is present along the axis, but here electron density is present in between the Cartesian axis. Electron density in between the axis, in between the axis, here along the axis, Are you clear? Now question is, which of the following pairs of d orbitals will have the electron density along the axis? Along the axis, which one? So this is along the axis, correct or not? Along the axis. Are you clear? These are between the axis, correct? Between axis, correct? Between axis these lobes are there. So these are between axis, but these lobes along the axis. Are you clear? So question is along the axis is asking density, electron density. Along the axis means which one? Dx square minus y square, dz square. That's which option is correct students? Dx square minus y square, dz square. Option C is the correct answer. Are you clear students? If suppose in the question they asked electron density is present in between the axis, means this option is correct. dxy, dyz, dzx answer you have to write. Okay, now see students, third question, the electrons occupying the same orbital are distinguished by. So the electrons occupying the same orbital are distinguished by same orbital electrons. So for example, I am taking here, see students, I am taking helium, atomic number 2, electrons 1 s2, atomic electronic configuration here, that means 2 electrons are there in 1s. Okay, now in same orbital here 2 electrons are there, correct? 2 electrons are there. These 2 electrons which is in which quantum number they are, both are differ, both can differ. So that is the question, students. That means here you calculate for this electron. First, for this electron I am going to calculate. So for this electron, okay, so for this electron, what is azimuthal? All values you calculate, students. What is n value? N, L, M, S. Okay, na? Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number for this electron. Are you clear? So for this electron, I am calculating. Now tell me, n value how much? 1 yes kada? N, here 1 indicates principal quantum number. So n is equal to 1. L indicates here L what? L is the azimuthal quantum number. For azimuthal quantum number, for S subshell, how much, students? For S value, for S subshell, 0. Correct? In the last, here I discussed you. Okay, now, here, yeah, see here, for S subshell 0, L value, P subshell 1, D subshell 2, F subshell 3. Are you clear? L value. So, just you remember that value, students, then you can easily answer this question. Now see, here n value 1, S subshell is there. For S subshell, L value 0, M value. For S subshell, how much? M value 0, correct? S subshell 0. Here, see Nana, here I discuss M values. See here, M values. Here see Nana, M values. M values for S subshell 0, for P subshell -1, 0, +1. That means here in P subshell 3 orbitals will be there now. Like this 3 orbitals will be there. 1, 2, 3. This is Px, Py, Pz anamata. Okay na? So these are the values. For Px -1, Pz 0, Py 1. So next one for D subshell. These are the values. -2, -1, 0, +1, +2. These are the names. dxy, dyz, dz. Okay. Now for S subshell M value how much? 0 kada? So that's why I'm taking 0. What is the spin quantum number? If electron is present like this clockwise direction, what is the S value, students? S value is +12. Correct? Here I told you. S is equal. If electron is present like this, what is S value? +12. Like this there means S is equal to -12. So that's why here +12 kada value. Right. Now this electron, second electron I am taking. Now second electron, it is in the anti-clockwise direction. N value, tell me again, 1 s kada. So 1 s means N is equal to 1. L value 0 for S subshell. M value for S subshell 0. For S spin quantum number value, this electron is anti-clockwise direction. So that's why S value -of. Are you clear? So that means N value same for both electrons. L value is also 0, same for both electrons. M value also same for both electrons, but S value different. For one electron +12, another electron -12. Are you clear this one? So that means they are differ by only spin quantum number. Remaining 3 quantum numbers same only. Only spin quantum number is differ. Are you understanding? So that means the 2 electrons which are present in the same orbital differ by spin quantum number. Remaining 3 are same. Are you clear? So what is the question? 2 electrons occupy in the same orbital are distinguished by azimuthal quantum number, principal quantum number, spin quantum number, magnetic quantum number. What is the answer? Spin quantum number is differ. Are you clear? This is the second question. Now coming to the next question, students. The number of d electrons in Fe plus 2. Fe plus 2, Z is equal to 26, is not equal to the number of electrons in which of the following. So first you have to calculate number of d electrons in Fe plus 2. After that, this all we have to find it. Now see, Fe plus 2 is asking. What is iron atomic number, students? Scandium, titanium, vanadium, chromium, manganese, iron. 26 kada. So argon, electronic configuration 4s2, 3d6. But here plus 2 is there na. Plus 2 means 2 electrons lost. That means which electrons lost? 2 electrons lost. From which orbital? From which subshell electrons losing? Valence shell electrons are always losing, nana. You remember, students, only electrons are plus 2 or plus 3, whatever it is there, that electrons that atom is losing from only valence shell. Are you clear? So that means which is the valence shell? Big shell number. Are you clear? 4, 3. Which is the big shell? Fourth shell. Are you clear? So that is valence. From the valence shell, it is losing electrons. Fourth shell kada. So from valence shell electrons are lost. clear this one? Electrons lost. You remember that one. What is valence shell, students? So that is big number. So big number only, big shell number only. Which one? It is the valence shell number. Are you clear? Just you remember this one, then you can answer. So from the valence shell only electrons are lost. Here valence shell is which one? Big shell number. So which is the big shell number? 3, 4, 4. 4 is the big shell. So big shell number. So that's it is a valence shell number. From the valence shell number only it is losing electrons. Plus 2 is there. Plus 2 means 2 electrons lost. Plus indicates lost none. Are you clear? 2 electrons lost. So that's why what is electronic configuration? 26 argon. What is electronic configuration? Argon 3d6. So this is a Fe plus 2 electronic configuration. How many electrons are there? Number of d electrons in Fe plus 2. In Fe plus 2 how many d electrons? Total 6 electrons it is having. Are you clear? 6 electrons are there. Now is not equal to number of, here also we have to find how many d electrons, how many ps electrons, p electrons. So that number should not be equal to the Fe plus 2 electrons number. So that is the question is asking students. See here, first option I am calculating iron d electrons. So iron d electrons how much, students? First option iron 26, argon 4s2 3d6. How many d electrons are there? 6 electrons are there. So that means here how many electrons? 6 electrons. Same kada? Here Fe plus 2 same. Here also iron same. First option. Now coming to the second one. See students, in the second question what given? P electrons in Ne. Neon atomic number 10 given. Means what is the electronic configuration? 1s2, 2s2, 2p6 kada? Here asking only P electrons. P electrons in Ne. Well, how many P electrons are there? 6 electrons there. So here also how many electrons? 6 electrons we got. That means it is 6 electrons. So Fe plus 2, 6 electrons, so same only. So this is the wrong option, which is not equal. Both are equal. Now see, S electrons I am going to calculate. As magnesium kada, magnesium atomic number 12, 1s2, 2s2, 2p6, so 3s2 electronic configuration. Now he is asking only S electrons. How many S electrons are there, students? Here S there, here S there. Yes. How many S electrons? 2 plus 2 4, 4 plus 2 6 electrons are there. So here also same we got. So fourth option we will check. Chlorine atomic number 17, 1s2, 2s2, 2p6, 3s2, 3p5. Correct? P electrons asking. How many P electrons are there, students? Here P, here P. Total 6 plus 5, how much? 11 electrons are there. So here Fe plus 2, how many electrons? So we have 6 electrons. But in the chlorine 17, how many P electrons are there? 11 electrons. Both are not equal. That is the question. Which option is not equal is asking. So option D is the correct answer, students. Are you clear? So like this you have to find it. Now see students, fifth question. What is the maximum number of electrons that can be associated with the following set of quantum numbers? N equal to 3, L equal to 1, M equal to -1. Now see students, N equal to 3 is nothing but which shell? Third shell. L equal to 1. L equal to 1 means which subshell? P subshell. And M equal to -1. 3p is nothing but it is having the 3 subshells. Now M value how much given? -1 given. -1 is nothing but here for which subshell -1 we will get M value? Px, Py, Pz kada. So -1 is asking. So Px is equal to -1. Okay na. Px is equal to -1. Py is equal to +1. Pz is equal to 0. So here they are asking Px. -1 kada. These are which values? So M values. Are you clear? So M values -1 for 3px. So what is the maximum number of electrons present in the 3px asking? Only px asking. So for example, this is the px. Are you clear? This is px, py, pz. So we understood this is -1 value is belongs to px. So px is px orbital. How many electrons will be there, students? Actually maximum electrons, how many electrons can be accommodated? Only 2 electrons. Are you clear? So 2 electrons can accommodate. So that's why option B is the correct answer. 2 electrons. What is the maximum number of electrons that can be associated with the following set of quantum numbers? Here what given, just you remember, n equal to 3 means third shell, l equal to 1 means p subshell, 3p just you draw p subshells, and after that m equal to -1 given. -1 is nothing but it is equal to px. Only px electrons are asking. Only maximum how many electrons can accommodate px? 2 electrons. Option C is the correct answer. B is the correct answer. Okay, Namma? Are you clear, students, this bit? Understood, Amma? So px value how much? 2 electrons can accommodate. So option B is the correct answer, students. Are you clear? So these are m values. Now, understood, Amma? So I hope you like this video, students. So total here 5 questions, previous year's questions I solved, Anna. Okay, solved, students. I hope you like this video. If you like this video, please like, share, comment and subscribe my channel, Nana. Thank you very much, students. Please support me. Okay, then I can do still more videos. Please try to understand. Please, students, please subscribe my channel. Thank you very much.